Good morning, everybody, and welcome to today's DrayTek webinar. I'm Julian Hubble, the Sales Director for DrayTek, and I'll be introducing this webinar and shortly handing over to our presenter today, Alex Schucker, who is our CTO. So today's webinar is entitled DrayTek Router WAN Performance and Hardware Acceleration. This is a topic that seems very popular with the various organisations that contact us. Networks are getting faster. Organisations have purchased DrayTek routers and want to get the absolute fastest they can out of it. And this webinar really covers all those aspects. If I could have the next slide, please. So we're going to cover a number of aspects of hardware acceleration. Alex is going to give a little bit of background to the type of speeds that are available out there. We're then going to summarise the different capabilities and performance of our different range of products. Obviously, we have our SOHO routers, we have our business class routers, and we have our firewalls. They've all got different capabilities. So we'll start with just summarising that so everybody kind of knows where each product fits. Then going to describe what is hardware acceleration, what does it mean, going on to how does it actually work within our products. And then we're going to talk about some of the implications. So if you're fine-tuning a firewall or a router to go as fast as it possibly can, it does have an impact on some of the other features. So we'll be careful to ensure you will understand what gets impacted when you turn on that go fast on a router. There'll be a bit of a config guide as well. So we'll take you through how to set up hardware acceleration, some hints and tips and best ways of doing it. And then finally, we'll cover some troubleshooting. So what can you get on when throughput, what issues can you come across, and what's the best way of overcoming the common issues that you find. Finally, there'll be a Q&A, which I'll come back in and host. As I say, we'll summarise the key questions that all of you have asked. Maybe time for some live ones as well, so please do be active in asking questions, and we'll get to that somewhere at the end. It should be done within an hour, probably around about 45 minutes presentation, and then 15 minutes at the end just to summarise. So without further ado, I'll hand you over to Alex, our CTO, who will take you through the rest of the webinar. Alex, over to you.
Thank you very much, Julian. Good morning, everyone. So as Julian covered, we're talking about hardware acceleration today and the performance of DrayTek routers. So I'd like to start by giving a bit of background of the current WAN demands on routers and how this is gradually increasing as we're seeing rollout of new technologies. The current being GPON-based for fiber, that's fiber to the property rollouts. And let's take a look at the stats of the DrayTek routers. But first, let's take a look at what we're seeing in the kind of changes in speeds. So here's some data from Ofcom. They released telecoms and broadband data kind of research, and that tends to be released every quarter, and the latest stuff they've released at the moment shows that the average speed that people are actually obtaining, if you look at all the connections, kind of residential connections in the UK and look at the average, it's moved from an average of 36 megabits per second in 2017 to 50.4 megabits per second in 2021. I see there's an increase, but that increase is, I think, underestimated a bit because that also includes all the slower connections that are on ADSL or VDSL. Whereas if you look at connections that are just cable, the average speed is 100 megabits per second. And if you look at connections that are just FTTP, the average is 145 megabits per second. So we're seeing a dramatic increase there. And if we look at the availability, the percentage of people who can order a connection that's 100 megabits per second or higher was 14% in 2017. Now it's moved up to 24% in 2021. And that is, as the rollouts continue, that's increasing. And if we look at the slower connections, look at the ADSL footprint of current connections, there was in 2017 about 2.8 million, which was 50% of all connections were just on ADSL. So that's a connection that's going to be up to around 8 megabits per second. Now that's shrunk to just 4 million, which is 16% of all UK connections are on ADSL, which means that the converse is there's a lot of connections that are now on something better than ADSL. There's still quite a few connections on VDSL, so that's kind of fiber to the cabinet type technologies rather than FTTP. So the fiber to the cabinet ones are typically maxed out at around 80, but as FTTP rolls out and people are able to migrate, then we'll see increases in that. And the FTTP availability currently is 28%, so that means that 28% of people can, in theory, order a FTTP connection, and the availability of 1 gigabits per second is weirdly higher, which is 38.9%, but that's because it includes cable broadband as well. So there's quite a large cable network in the UK run by Virgin Media. So of all the properties in the UK, about 38.9% of people can, in theory, get 1 gigabit per second, but that's not necessarily reality for some people because it kind of depends what's available in your area. But as rollouts increase, that's going to be a better picture for people. The government target is 85% of properties to have FTTP, but actually no, 85% of properties to have 1 gig capability by 2025, and that's looking like it could be met, primarily I think from the cable side of things, but the FTTP is rolling out. And if we look at BT's quarterly financial results, the latest they've released, they reported that Openreach's build costs of rolling out their FTTP network have been lowered as well. So it's costing them about £250 to £350 per property passed for them to deploy their infrastructure past people, and that's a reduction compared to the previous estimate of £400 per property. The result of that is that their funding is going to stretch further, which means that they should be able to roll out for more properties for the current funding that they've kind of committed. And if we look at Virgin Media, they've got DOCSIS 3.1 rollout, which is enabling 1 gig speeds for their cable customers, and also they are increasingly rolling out FTTP themselves as well to upgrade their network, which should result in them being able to offer an improved network in the future. So if we look at some kind of broadband packages that are available, the way that it's described, you've got fiber connections for fiber packages, but these are often just actually VDSL connections, fiber to a cabinet. So they're typically advertised around up to kind of close to 80, often a little bit less for kind of because they don't know what a customer is going to get. So it might be around 73 megabits per second, but these are not really fiber connections. So these are not the ones we're kind of interested in when it comes to high performance. It's the full fiber packages that are ones that are going to be causing higher demand on routers. So something like full fiber 900 will give you a 900 megabits per second download speed, and we're seeing this from other providers as well. So that's with BT, and then with Virgin Media, there's the Gig 1 fiber broadband package that gives 1 gig broadband. And also look across to Ireland, Air have a 1 gig fiber. They've got their own rollout as well, where they're deploying more fiber connections. And there's also in the UK other providers other than Openreach and Virgin Media, so HyperOptic offering some hyperfast broadband packages depending on which areas they're covering, and also there's larger rollouts by some other ventures. CityFibre is one of them. They have partnered with various people. You can't actually get and CityFibre is not an ISP, they just do the network and then they partner with ISPs who will sell the packages. So people like Zen, Vodafone and others will resell CityFibre's network. For example, Zen have a 1 gig package that you could get. The availability of that is dependent on the area. So the checker.ofcom.org.uk is a good checker to use. If you put your postcode in there, you can see what networks are in the area. Here's an example, which was, I can't remember which postcode I use now, but that's showing Virgin Media, Openreach and CityFibre as the ones in the area, and you can see the connection speed that is likely to be available is 1 gig, but a customer would need to actually go to the different providers to check the direct availability, because this is just approximate. So we look at that, the trend is towards faster connections. So let's look at the DrayTek products and the product capabilities and performance to see where the routers stack up and what we can push them to. Here's the router comparison chart from the DrayTek site. I've condensed it just to focus on some of the performance figures. Got all of the models across the top, so the 27, 28 range and 29 range, and the 29, 62 and 39, 10. We can see that the max firewall performance we're stating here is around up to kind of 950 megabits per second for many of the range, and then for some it's above 1 gig. That's because of dual WAN. So if you've got a dual WAN, we're talking about the total firewall capacity rather than what can be obtained on an individual WAN, because if you've got a 1 gig interface, you're not going to be able to get more than one gig on that. So that's why some of the figures for the 2865 and the 2927 are higher than 1 gig. The other products at the far right are our highest performance ones, the 2962 and the 3910. I'm not going to be covering hardware acceleration with those because they're different architecture. So they're both in their own right very capable products and have a different architecture compared to the other models. And the CPU on them is a different class, so they can deliver very high WAN and VPN performance without any need to enable hardware acceleration as such. The 3910 is rated up to 10 gigabits per second firewall performance and 3 gigabits per second VPN, so very high spec. So the performance figures I've got here have VPN IPsec listed as well, and SSL VPN. Now the figures on this chart are where we've got hardware acceleration enabled. That's so with that enabled, we've got the max figure, and I'll show the differences with it enabled and disabled in a little bit later. If we look at some of the older models as well, we've got the 2860, 2862 and 2926 for comparison. Those, the 2860 has a max of 300 meg, 2862 is a max of 400 meg. That's without hardware acceleration, comparing to the current products, and the 2926 is the same as the 2862 CPU wise, so it will be the same performance. And I'm going to talk a little bit about the impact of enabling hardware acceleration on those older models as well, just so you're aware, because people might have connections that they're upgrading from VDSL to FTTP, and I just want to share some information on what you can expect from some of those older models when it comes to being able to use that on the newer connections. So let's now just take a look at what hardware acceleration is and how it can help us. So hardware acceleration is a way of reducing the demand on the CPU by offloading some of the processing to a dedicated resource. It's an optional feature that you can enable on routers. Without hardware acceleration, the router CPU will do all the processing, and it's able to deliver pretty decent performance and an array of features at the same time. But to increase capacity, we can enable hardware acceleration to allow it to offload some of the routing to the hardware accelerator, which then reduces the load on the CPU and allows some gains in the top level performance. With hardware acceleration enabled, it can accelerate up to 8,000 sessions. Any sessions above that would just be processed by the CPU as normally, so you don't lose the number of sessions that you can run through the router. For example, might be 60,000 sessions in total, but it's just the first 8,000 of those would be capable of being hardware accelerated. So we look at the impact of enabling hardware acceleration. At the top here, I've got the 2927, 2865, 2866, 2765, and 2766. These are all a similar CPU, and with hardware acceleration disabled, the NAT and WAN performance would be 600 megabits per second. If hardware acceleration enabled, it goes up to around kind of 930 megabits per second, or a slight bit higher. I'm being a bit conservative there with the total number. And with IPsec, with hardware acceleration enabled, you can get 800 megabits per second. Without it, the dedicated IPsec processor can do 300 megabits per second. And then if we look at the 2926 and 2862, the older model, that has a WAN performance of 400 megabits per second without hardware acceleration. So actually, for some FTTP connections up to around 300 megabits, it's still quite capable. But with hardware acceleration enabled, you can get it up to 930 megabits per second, which allows you to get a bit more juice out of it to be able to keep using it for a bit longer potentially. So what traffic can be accelerated by hardware acceleration? Well, there's a few packet types that can, and then there's some that can't. So the main thing is TCP and UDP IP packets can be accelerated by the hardware accelerator, and also IPsec ESP traffic that's generated by the router, providing it is one of the protocols I've listed there with SHA-1 or SHA-256. other protocols can't be accelerated. So I'll talk about that in a little bit on some of the limitations. But most protocols you'll find will be UDP or TCP when it comes to kind of real world usage. So the vast majority of stuff can be hardware accelerated. So when is hardware acceleration not needed? Well, if it's on DSL, so if it's a ADSL or a VDSL or a GFast connection, then it's not going to need hardware acceleration because the router's native performance can easily cope with any of those speeds. So if only using on DSL-based WAN, then you wouldn't need hardware acceleration to be enabled. For example, I've got a screenshot here of the VDSL connection speed here. This is got a 60 megabits per second connection, but VDSL only goes up to 80 and GFast only up to around 330. Also, if the broadband connection is less than 600 meg, if it's FTTP, as I've shown, the router can, the 2865, for example, can do up to 600 meg itself without hardware acceleration. So how does hardware acceleration work? I'd like to just talk about some of the technicals of how the mechanism works to give you a better understanding of what's happening under the hood. So how it operates is on a packet basis. So I've got a flow chart here that at first glance is a bit to take in, but I'll just talk it through and explain how it operates. So when a packet comes into the router to be processed, either one that's received on the LAN or one it's received on the WAN, it runs through kind of a sequence of activities. The first thing it does is it, if I just use my cursor here, it checks to see if it is in the PPA table. That's the the protocol of the processing accelerator. And if it's in the table, if the session is already in the hardware accelerator, it means that it can be accelerated. But let's just run through assuming it's not. So if it isn't in the PPA table, what next happens is it goes through the CPU checks. So the CPU will go through all of the features. So DDoS, bandwidth limit, the IP filter, QoS, and then the user management session limit, app enforcement, firewall control, URL content filter, the web content filter and DNS filter, and it'll process all of those functions and decide whether or not it wants to pass the traffic or not, or do any specific activity. If it wants to drop it, then it will just drop the packet and take no further action. If it has decided it will pass the traffic, then it will go to creating a flow. And then it will check to see whether or not this packet can go into the PPA. So is it UDP or TCP, or is it an IPsec packet that can be accelerated? If it can, then it will check to see if hardware acceleration is enabled, and if it is, it will then go into the PPA engine. When it goes into the PPA engine, a session will be created in the PPA table, and then it will send the packet out. And then any subsequent sessions, it will match against it because it in the table puts in the IPs and destination IPs ports. So when a packet comes in, it will then match it again in the future to then, if we think of another packet coming in, if it's in the table, goes to yes, and then it will send the packet out quickly without having to go through the CPU, and then it won't cause any load on the CPU. If the packet comes in and can't be processed by the hardware accelerator, then we get to this CPU slow path section here. This means that the CPU will do the processing. So it's just that the slow path, just the term that we use, just we call it that means that it's processed by the CPU, and then it will get the total capability will be up to the 600 megabits per second, and the packet then flows out. So that's a general overview of how hardware acceleration operates. As I said earlier, it can do up to 8,000 sessions on the current models. The older models, they support slightly less sessions. That's a combination of the packet accelerator engine, which is the hardware accelerator, and also the MPE, the multi-core processing engine, which is hardware acceleration done by the CPU. So the hardware accelerator can accelerate 2,048 sessions using the hardware accelerator, and then additional to that, then it can do up to another 5,952 sessions with the CPU's hardware acceleration, which gives a total of 8,000 that can be accelerated. And if you go above that 8,001, then that packet would then go through the slow CPU path. But The sessions that expire will then be recycled. So if a session's expired, then it can be relinquished and can then allow a new session to go into the hardware accelerator. So the mechanism in the table, it records the MAC address and the source IP, the destination IP, source port, destination port, protocol, and the NAT info, so that it can then process it again. The MAC address is really important for it. If it can't record the MAC address, then it's not able to do the hardware acceleration. So it's important for the router to be able to see the MAC address of the LAN device that is doing the hardware acceleration for. The TCP traffic will be accelerated after the three-way handshake's completed. So the fourth packet will then go into the PPA, and UDP traffic is after 3 packets. The third packet will go into the PPA. And IPsec traffic, as I mentioned, if it's ESP, and also with any of those protocols. So that means that AH mode isn't supported, but it does do IK V1 and V2 can both be accelerated. But what can't be accelerated is NAT traffic. So if it's IPsec where the router's behind NAT, where NAT traversal is taking place, then the hardware accelerator can't accelerate that IPsec traffic. And if it matches a QoS rule, then a tag is added, and then any sessions that match that are then processed by the hardware QoS function. So it doesn't look at the matching at each packet, it looks at it for a session. So as soon as a session occurs where it gets tagged at the beginning, then all of that will then be put into that QoS class. That does mean that if you've got a session where for one session there's multiple different QoS tags, it will only use the first one, but it's quite rare for an application to do that. Normally each stream would have its own QoS class. So now that we've looked at hardware acceleration, I want to just cover a bit on some of the limitations to understand and explain which traffic can't be accelerated, and also the impact of enabling hardware acceleration, because there are some features that are incompatible with hardware acceleration. So what traffic can't be accelerated? Well, the first thing is routers, VPN services can't be accelerated. So anything that's not IPsec, so for example, PPTP, LTTP, SSL, and OpenVPN, they can't be accelerated. But the router, the latest mod has pretty good performance, though, as we've seen on the stats, that performance is without the need to have hardware acceleration. And also FTP. So the FTP signaling port can't be accelerated because there's a SIP out that's doing things to help FTP pass through NAT, but the actual data is okay. The FTP data port so will get accelerated, and DNS traffic doesn't get hardware accelerated. This isn't much of a concern because DNS doesn't actually have much bandwidth usage. It's more about resolving host names, so it doesn't affect the actual throughput of a download. It's just the resolution, and the reason for this is because it's checked by the DNS filter service, so that the router can do various DNS functionality to do the kind of LAN DNS function or the DNS filter, and also sessions to the router's local services. So things like HTTPS, SSH, DNS, and as I mentioned, the VPNs, those are unable to be accelerated, but that shouldn't cause much of an issue because you generally don't have a really high download speeds. The web interface of the router is not that massive that it needs to be running at multiple megabits per second to be able to load the page. And also traffic from a non-directly connected LAN. So this is more of a rarer one, but it's something that if you've got a more complicated LAN with multiple different subnets behind it, the router can't accelerate the traffic if it can't see the MAC address of the device. And also if it's an IP address range that it doesn't know about. So if it's something where there's some routed IP addresses inside the LAN that then goes to the router with maybe more routers and switches in a complicated network, then in some situations the hardware won't be able to be accelerated. So the main thing there is where the router isn't able to tell the device's MAC address, because the MAC address is really important for putting into the hardware acceleration PPA. And as I mentioned, traffic there isn't TCP or UDP. that means kind of GRE, ICMP, anything that's pure IP and others. It reasonably rarer traffic. Most traffic tends to be UDP or TCP. So any higher protocols like HTTPS, that's TCP, so it can be accelerated. Same for web browsers that are using UDP for transfers. That's fine. But it's just those specific other protocols that aren't based on TCP or UDP, and also fragmented packets. So if you've got a TCP packet that is fragmented, that's not going to be accelerated due to the nature of the fragmentation. So we touch on that when we look at how to troubleshoot some issues, because if maybe the WAN MTU is set incorrectly, that could cause some fragmentation, that can then affect the ability for hardware acceleration to operate properly. And on IPsec, there are some limitations as well. It's incompatible with MD5 authentication, which isn't much of a concern because that's a lower level authentication. You should be using AES, so that's fine. And then AH mode, also that's a less secure mode compared to ESP, but it can't accelerate IPsec. But one thing, if you are doing LAN to LAN, just check that it's not by mistake set to AH mode. Make sure that it's set to the ESP mode, and also IPsec where NAT reversal is being used. So that's if the router is behind NAT, so it's got a private address and the other end is having to do NAT reversal for the VPN, then that means that the IPsec can't then be accelerated by the hardware accelerator. So it's not typically an issue for standard LAN to LANs where a router has a public IP address, but there are some scenarios where NAT reversal can be in play, and that would prevent IPsec from being accelerated. And the final thing on disadvantages is some features that are incompatible with hardware acceleration. It applies more to some of the older models because with the current range, we incorporate more things that can be used in conjunction with hardware acceleration. But things like, for example, DOS defense is bypassed for sessions that have been accelerated. So it will be checked when the session first comes in, but once it's been passed, then that specific session is then accelerated. The bandwidth limit function doesn't work for sessions that have been added to the PPA, because once it's put in there, it's just going to get really fast speed, and the bandwidth limit function isn't able to monitor that. SD-WAN reporting on application data usage isn't compatible with hardware acceleration, and the hardware QoS doesn't allow dynamic reallocation of the classes. So the class 1 to 3 quotas are only assigned to the specific classes. So what we'd recommend when setting up QoS is to typically use the class 1 for your important traffic, and then use the others class for other traffic. And there's no app QoS for the inbound direction. App QoS is where you're applying QoS based on the application that's detected. That isn't able to function for the inbound because of the order of how traffic is processed. It would go into the hardware accelerator before the app QoS function is able to inspect the traffic. And the firewall filters bypassed for traffics that have already been approved. As we saw, the CPU check includes the firewall, but if the session has already been checked by the firewall, then subsequent packets are automatically approved. So it means it doesn't get looked at again for that session. And older models are incompatible with some of the functions. So QoS, bandwidth limit, session limit, and the data flow monitor can't be enabled if you want to use hardware acceleration on the older models, but that doesn't apply to any of the current range. So let's have a look at how to set up hardware acceleration. It's quite straightforward. There's not much to enable, but I'll just talk you through that. So we go to the hardware acceleration menu on the router and select enable, and then choose what we want to enable. We've got NAT, so that's TCP and UDP, and then IPsec to tick those for TCP and UDP. If you tick NAT, it also does routed as well. So it will also include NAT or non-NAT traffic, can be hardware accelerated. And that's all you need to do to enable that. On some of the older models, there's another mode called manual. That's because it could accelerate less sessions. So there was an ability for you to pick specific hosts that you wanted to include in the hardware acceleration to kind of prioritize those. That's not really needed on the new models because it increases a lot more. So you just can set that to auto or manual. But if you set it to manual, you set TCP and UDP, but then you would specify the host that you want, or you could just tell it to accelerate the heaviest sessions. Also on older models, you'd need to disable some functions. So you'd need to disable the QoS, the bandwidth limit, and the data flow monitor. If those are enabled, enabled, then it would prevent hardware acceleration from functioning, so you would not get the benefits of hardware acceleration. And also on some of the older models, 2860, 2862, if WAN 1 is enabled, that can affect the WAN 2 hardware acceleration. So you would, if you're not using WAN 1, disable WAN 1 to get the full benefits of hardware acceleration for WAN 2. An example of this might be if you've got a 2862 where you used to use it on VDSL on WAN 1 and you've been updated to FTTP and you're now connecting to WAN 2, then what you would do is disable WAN 1 and enable hardware acceleration to get the full benefits of hardware acceleration for your new fast WAN connection. These steps are not required on the current range of models. Also, there's an exception list, so you can add in entries to bypass hardware acceleration. To do this, in the menu, you put in the MAC address. You can click on that ARP table button there, which will then give you a list of the MAC addresses that are on the device to save you clicking, typing in, and then you can pick the exception type, and then you can give a description so you know what entry you've added in there, and then once it's added, it will show you that it's been added into the exception list, and then that means that traffic from that device will not be hardware accelerated. So you can do this if there's devices you don't want to be using the sessions, or if there's any issue you happen to have come across and you want to just bypass hardware acceleration for a specific device. Once you've got hardware acceleration enabled, you can check to see if it's functioning by looking at it in the command line. The command PPA-V will show you the status of hardware acceleration. So we can see if it's enabled or disabled, what it's enabled for, and also we can see the number of entries that are in the hardware acceleration. Also, we can look at current sessions. So PPA-D3 shows you the LAN sessions, and PPA-D4 shows you the WAN sessions that are currently in the hardware acceleration table. So that concludes the setup. Let's now just run through some stuff on troubleshooting to give you some tips of just general things on WAN connection speeds, but also stuff specific to hardware acceleration. So if you're seeing any WAN performance issues, one of the things I recommend doing is check to see if other devices are also affected, just to see if it's something specific to a single device, and also are wired and wireless devices affected as well. So that can help narrow down to understand where the issue is, and also check the data flow monitor and traffic graph to see what sort of speeds other devices are getting. It could be in some cases that you've got a device that's using up a lot of the bandwidth, and that's maybe affecting a speed test that's doing. And also check the online status, the RX and TX rates, because there are sometimes things like VPNs that can be using up bandwidth that you might not necessarily see in the data flow monitor, but can be hidden. So if you look in the online status page, you can see the RX and TX rate to see what current rates going through the WAN connection. And also, one thing you can try is maybe a PC or another router directly to the connection, just as a sanity check to see to try and identify if it's related to the router or not. A common thing that we've seen is sometimes the negotiated speed with the connection. So that's an important thing to check. For example, if the router is connected to its Ethernet port to the upstream modem and the speed negotiated is only 100 megabits per second, then that would give you a limit. You wouldn't be able to get above 100 meg. So that's something we have seen in the past. So you can check the status of the negotiation by going on the CLI and looking at port status. And we can see there, in this example, the WAN 2 is set to 100 meg, which has been negotiated. So sometimes the Auckland negotiation can go wrong in some situations. So it's possible to set that manually. So you can do that by going into the WAN menu and setting the physical type. So here, WAN general setup, and then choose the negotiation type. So we'd pick 100 meg full duplex, or you can set it manually via the CLI. If you look at the port space question mark, that will give you the syntax for the command. And also flow control. It's important that flow control is enabled. So port WAN FC, which stands for WAN flow control, question mark will show you if that's enabled or not, and you can manually enable that as well if there's some reason that it hasn't auto-negotiated. Another thing that can sometimes cause throughput issues is UDP flood defense, because the default settings are kind of for lower speeds. So you might find that the default thresholds actually get triggered by just genuine traffic. So if there's a note at the bottom of it that shows you a general guide, but if you've got, say, a 300 meg connection, then you want to set the threshold to be 25,000 packets rather than the 2,000, because otherwise the UDP flood control would kick in and stop the traffic. It then can be a little bit confusing because it only stops it for a short period of time, so it can end up being bursty. So you can end up with good traffic, good throughput for a bit, and then it stops, and then it goes again and stops. And that sort of symptom tends to be due to the DOS defense, UDP flood defense. So that's something to look at. And if you're finding the throughput isn't what you're expecting and hardware acceleration enabled, check to see if there are any entries in the PPA table. You can look at that by the command I gave before, PPA-V, and check to see that there are LAN and WAN entries. If there's none in there, or there's a lot less than you would expect, then there may be some reason that the traffic's not being accelerated. So that's then an avenue to look down. If you're seeing, for example, it's only there's lots of LAN entries but no WAN entries, then that would be suspicious as well. Typically, there's generally the same amount of LAN entries to WAN entries. So if you're seeing a difference there, maybe with LAN entries but not WAN entries, and that could be an indication that something's not happening quite right and not going into the hardware acceleration. So we'd need to check the ARP table and make sure the device that you're using is included in the ARP cache table, so that the MAC address of the physical device needs to be in the router's ARP cache table for it to then process it in the PPA. So you can check that to make sure that it's in there. And as I mentioned earlier, there's some incompatible features. So if you're seeing low bandwidth, just check to make sure that those features are disabled if you're looking for hardware acceleration. I mean, those can be enabled and you can still get decent throughput, but it's if you wanted to get the max, then with hardware acceleration, these would need to be disabled. And also, as I mentioned, the WAN 1, if that's enabled on some of the older models, that affects the hardware acceleration for WAN 2. So with WAN 1 enabled, you can't get TX hardware acceleration for WAN 2. So you need to disable WAN 1, and then you get RX and TX hardware acceleration on WAN 2. This is only on older models, not any of the current, so 2865, 2765, 2927 and later are not affected by this. And also check incorrectly configured QoS. If the QoS is set to a lower speed than is actually available, then that can mean the QoS can be kicking in artificially and limiting the traffic, throttling it when it doesn't need to. So go into the QoS menu there and check to see if it is enabled. And another thing is the MTU. So if the MTU is set incorrectly, it can be inefficient. If it's set too low, it can be efficient. If it's set too light, it can be inefficient. But one of the biggest problems is if fragmentation is occurring. Because if there's fragmentation, it means that the hardware accelerator can't accelerate the traffic. So check that the MTU is set appropriately for the connection. You can use a feature called MTU path discovery. You click on the detect, it pops up a box, and it allows you to put in some test packet sizes, and then it can help try and discover the correct MTU. So you can then set that appropriately to avoid any unnecessary fragmentation. And also, if traffic can be accelerated, it needs to be in the NAT session table. So it's useful to check the NAT session table to see that there are entries in there for the devices that you're looking to get accelerated. So that's run through some troubleshooting tips that I hope are useful for you. So in summary, so as we've seen, with hardware acceleration enabled, you can improve performance to something near 1 gigabit per second, and covered an overview of kind of some of the limitations, for example, with IPsec behind NAT, and if IPsec's not, if it's AH mode, not ESP, and some stuff with the things like on older models, the QoS and bandwidth limit, session limit, data flow monitor, and the SD-WAN reporting. But as we've seen, without hardware acceleration, the performance is actually quite high on the current models, up to 600 meg. So you don't actually need to use hardware acceleration in all cases, but you can do though. If you use hardware acceleration on a lower speed, there's not necessarily any harm in doing that. You can still get the high performance, but also it might allow additional features to be used, perhaps if there's a lot of functionality, because if the CPU is not using the processing for the throughput, it might give more for SSL VPN, for example, for it to process that. So you can get some benefits. And as we've seen, older models do support it, but have less. But the newer models have less drawbacks because the latest hardware has got a better hardware acceleration. And as we've talked, hardware acceleration only applies to UDP, TCP traffic, and the IPsec as well. So that's everything from me. Thank you. Now I'd like to move to a Q&A to see if there's any questions that people would like to ask. So I will hopefully be able to invite, Julian.
I'm here, yes. Thank you very much, Alex. As ever, quite a good deep dive there into this particular topic, and a really good flow. I think that really followed a good process there, and I'm sure that's hugely beneficial to many people on the call. In fact, we had some very good feedback already, actually. So I think the first question, probably the most obvious one, and one that perhaps I should have mentioned earlier on, this webinar is being recorded. So quite a lot of detail there. If you want to come back into this and see the bit that was most relevant to you, it is going to be recorded. It has been recorded, and you will get an email shortly after this webinar closes showing you where to find it, so you can stream it at your leisure. So that's kind of the first basic question. So a few others here, Alex, if you don't mind. So obviously hardware acceleration can be hugely beneficial. And there's a question here asking why it's not on as a kind of default on DrayTek routers. In other words, when you get a DrayTek router out of the box, why is hardware acceleration not enabled as standard, and you kind of disable it down rather than the other way around? So that's the first one. And a kind of partial questions are, what are the downsides? I kind of think you covered a little bit of that, but you may want to expand a little, and also kind of best practices. So any generic advice you've got. So sorry, 3 questions there.
Thank you, Julian. Yeah, it is a good question about why is it not enabled by default. It's a common one we have had when talking to people about hardware acceleration. I think the main reason is because historically it really wasn't needed, because the router's native capability was always been designed to cope with the typical connections around, and when the majority of connections are on fiber to the cabinet based kind of VDSL where the max is 80 meg, that's really no problem for the range. So hardware acceleration was unnecessary to enable, and all it would do is potentially cause some issues with some of the functions, and especially since the older models had more limitations. When hardware acceleration enabled, there was more drawbacks, so it meant that just by default we were leaving it disabled, and when the new model came out, we just kept with the status quo of having it disabled because that was in the previous config rather than changing anything. And also, in some ways, I guess it's an easier life when it comes to support. It means that there's less potential issues. So it's when hardware acceleration isn't typically needed, it's kind of it's easier to leave it disabled. But part of the reason why we're doing this presentation and including more information for people about hardware acceleration is so that people can be aware of how to get that boost with the maximum connections as more and more higher speed broadband connections are becoming available. The other part of your question, I think, was about some of the downsides.
Yeah, what are the ups and downs? Yeah, this kind of what are the downsides, and also there was a kind of best practices, I suppose, more generically. You know, what sort of environments might be suitable for it, and what sort of environments may not be. I don't know whether you could just answer
I think
generally.
Typically, if it's DSL, there's no need to enable hardware acceleration on it. So I would typically not need to enable hardware acceleration if I'm using DSL, but enabling hardware acceleration on the Ethernet WAN stuff is quite good to do by default. It doesn't have that much impact, and I've been using that on a few different devices. That's been working quite well. It generally will mean that there's less CPU loading, so it does mean that other functions have more resource available for them. So that allows things like SSL VPN to be less impacted. If there was a lot of bandwidth and IPsec, and then SSL VPN might performance might be impacted, but by having hardware acceleration enabled, you're giving more CPU time for other things that have to go through the CPU. So that can sometimes be good to have enabled.
Okay, so it sounds like if it's Ethernet WAN, that's kind of where you're going to get the most benefit in it from what you said there, Alex. Okay. Second question here is regard to kind of multiple WAN connect. I think you've kind of part answered the question actually. So it's basically saying if you've got WAN 2 disabled and you can only use one WAN, can we use the maximum throughput of the router? So,
okay,
so I guess it's kind of saying if you're blasting across 2 channels, maybe it does one thing. If it's across one line, is there a difference? So.
Yeah, I guess there's 2 ways of answering that, depending on whether it's a model that supports DSL or a model that supports Ethernet WAN. So on the DSL WANs, if WAN 2 is enabled, then the only WAN that's been enabled would be WAN 1. So there would be no limit in any rates because the DSL performance is much lower than the router's capability. If WAN 2 is disabled and you've got WAN 1 and it's a gigabit WAN, then you can use the maximum of up to 930 megabits per second of the throughput. The stats we've got in the comparison chart has it higher than 1 gig. That's because you're assuming if you've got 2 WANs, then you can have bandwidth going across both those 2 WANs, which is why the maximum throughput listed is higher than the capability of an individual single WAN connection. Right. Okay. So hopefully that answers that. But if not, then if you reach out to us directly, we can kind of answer that in more detail, customer's specific query.
Okay, so I guess on the Ethernet WAN ports, if you use hardware acceleration, each one of those ports can theoretically get up to quite close to a gig. That's kind of what we're saying.
Yeah, and actually the hardware acceleration is per WAN as well. I should have said that.
Yes, okay, sure.
If you've got hardware acceleration enabled, the max is not 930, it's 930 per WAN. So you can get much higher performance on both WANs by having hardware acceleration enabled.
Okay, yeah, it's a great question. Great question. Okay, third one here is about usage of hardware acceleration when you've got other things going on. So the question is, can we use hardware acceleration in conjunction with quality of service? Is that going to impact that? And also a really good question on VoIP traffic as well. If you're going to turn hardware acceleration on, is that going to mess up the VoIP connections?
No, that hardware acceleration with VoIP is fine. That shouldn't be any impact. With QoS, it depends on how complex the QoS regime is. If you've got a lot of classes, then you might want to leave hardware acceleration disabled, because the hardware QoS is there, but it's not as flexible as the software QoS. So with the software QoS, you've got multiple different classes, and the classes 2 and 3 can use any spare bandwidth that class 1 isn't using, whereas on the hardware QoS, it's fixed. So the bandwidth you give to class 1 is allocated to class 1, and other classes can't use it. So it depends a lot on how complicated you're going to be with QoS. If you're just using something reasonably basic, then the hardware QoS is quite good and useful. But if you've got really complex schemes with the QoS, then you might want to consider leaving hardware acceleration disabled if you've got some specific kind of requirements when it comes to QoS.
Yeah, and I guess there's a kind of suck it and see as well. I guess you could apply it and see what impact it has and disable it if you don't think it's right. I guess that could be another best practice option there.
Yeah.
Okay. A final question I've got here is which models support the hardware acceleration feature? Obviously, we've got our 27 series, 28 series, 2027, and also the 3900. So is it available across the range, or is it only available on certain models?
Yes, it's all the range. So the 2765, 2766, those Soho routers support hardware acceleration. Also the 166, although it's primarily used as a modem, you can put it into router mode, and it does support hardware acceleration.
No, that's interesting, although that's kind of a DSL connection, isn't it? So would the same sort of rules apply that you mentioned earlier on, maybe ideal for Ethernet WAN connections, but not so much for DSL? Or is there a special case?
Oh, that's true, yeah. That's right.
Yeah, okay, cool. Okay, good. Well, I think that concludes all the questions, actually, which is great. So, so unless there's any more, I'm just going to wait a minute or two just to see if any more come through. But what I'm doing for that, can I thank everybody for joining the call today. It was very, very well attended, so clearly it's of interest to our partners and our customers. So hope that's useful, and we thank you very much for spending time in your valuable day joining us. Also like to thank Alex for an excellent presentation there. Nicely put together, lots of depth, and we really, really hope that's useful to you all. You will be getting an email afterwards with how to find this webinar for streaming in the future. And please do complete the survey. And I know it's a bit of a nuisance when you finish something, you want to go on with something else, but the feedback you give us on these surveys greatly helps us create future webinars. In fact, a lot of the content you see on webinars we do today came as a result of people giving their feedback. So please do give some feedback. We'd love to hear from you. And other than that, unless there's anything more from you to add, Alex?
No, that's everything. Thanks, Julian. And
Okay.
yeah, do give us any feedback on future topics you'd like us to do some deep dives into. So if there's kind of interest in that, then we'll happily run more of those.
Great stuff. Well, thank you very much once again. Have a great day, and we'll see you soon on the next DrayTek webinar. Bye for now.